All right, so 5.3, polynomial division. You need to divide each term in the numerator with the denominator when you have one term in the denominator. So you're going to do this divided by that, this one divided by that. Oops, that one's missing an x for some reason. This one divided by that, and this divided by that. So 12x to the 5th divided by 3x squared, then minus 15x to the 4th.
It's not showing what you're doing.
Oh, I'm not sharing. Thank you. Let me get back to that screen. I hit record, but not share. Okay. Share screen. Okay, let's get to... All right, are we good now?
Yeah.
Okay, so we're dividing each, when you have only one term in the bottom in the denominator, you can divide each of them by that. And so you do that, you just divide each of them by the denominator. And so this is more of an exercise with rules of exponents and just simplifying fractions. So that can reduce to 12 divided by 3 is 4. This pen is not very smooth on paper. There we go. 4, and then x to the 5th divided by x squared would be x to the...
Wouldn't it be x to the 3rd, because isn't it with division that you're subtracting?
Yep, so you do 5 minus 2 and get positive 3. All right, then you have 15 divided by 3 is 5, and then same thing, you subtract, and then you cannot reduce 20/3, so you leave it as 20/3. You don't want to write it as a decimal because then that would be an approximation. And then same, 3 minus 2 is 1. But on this last term, when you do 1 minus 2, you'll end up with a -1. And so that ends up being a reciprocal where it goes on the bottom. So I like to think again of them as where are there more and how many more. There's more in the bottom, how many more? 1 more. And so some of them might have no x's left because they all cancel out. Sometimes the x's will be on the top, sometimes on the bottom. So just do what it ends up being. So that's when it's a monomial in the denominator. Then most of what you're going to end up doing are polynomials in the denominator, quite frequently binomials. So there's two methods, long division and synthetic division, that I wanted to discuss. Long division always works for polynomial division. Are you guys off? And so you set it up like normal long division. 3x to the 3rd minus 4x squared plus 2x minus 1. And your divisor out here, how many times is this going into it? And so then you start the process like you do with normal long division, except instead of digits, it's terms. So how many times does x go into 3x to the 3rd? That's kind of a weird question. We're not so used to that phrasing, but basically we're trying to whittle this down until we have a remainder. And so we want to get rid of this. And so the opposite of division is multiplication. So essentially I'm saying what here times x would get rid of this. So when you do long division, you always subtract. So we need these to match up. So 3x squared times x would be 3x to the 3rd. So if we make these match, then when we subtract, it goes away. You'll just have to make sure to multiply by both of these. It's like the distributive property. So I have that. What I'm going to do is I'm going to now subtract it, just like normal long division. If I had a number like 562 divided by 3, I'd say, how many times does 3 go into 5? One time. 1 times 3 is 3, and then I'd subtract, and then I'd bring down and continue on. So I'm at that subtraction stage right now. So this will go away when I subtract. That's why we want them to match, so that when I subtract, it goes away. And then here I have -4 minus 3x squared. So if you're not so fond of subtraction, you can also change this to adding the opposite. And I do that in a different color just to make it clear what sign I'm going to be following. It's going to be the -4 minus the 3. And then you bring down your next term. And then you're going to do the same thing again. X times what will get me -7x squared. So 1 times -7 will give me that -7. X times an x will get me x squared. So it's always what times this will get me this first number, or term, I should say. So this gives me -7x squared minus 7x. So I'm going to subtract that whole quantity. And again, you can change it to adding the opposite. And so I'm going to follow the blue now. That goes away. I have 2x plus 7x is 9x. And then bring down my next term. And I often actually bring down all my terms. That way I don't lose it if things don't line up nicely. All right, so now I want to get rid of 9x. So x times 9 will get me 9x. So 9 times x is 9x. 9 times 1 is 9. Positive 9. We're going to subtract that. And again, you can change it to adding the opposite. So the 9x minus 9x, that's gone. -1 minus 9 is -10. So that would be your remainder. And so you say minus 10 over your denominator. Or you could say plus a negative. And in the XYZ homework, if they have a fill in the blank type thing, they'll have a plus here, and then you put the minus up there. Because your remainder would be -10. So what happens sometimes is that you might have like a missing term. Like here you have no x's. It's good to put in 0x so that you don't accidentally combine unlike terms. So like, for example, if you had a missing square term and then you have this square term here, and you don't want to accidentally combine those because those wouldn't be like terms. So by putting in a 0, you're less likely to combine unlike terms. And the other reason for the 0, why I put it in, is because when you do synthetic division, you will have to put it in. Okay, so this one has 2x minus 5 as its denominator. So we're going to be doing 2x times what is 2x to the third. And then remember to always multiply by both those. So 2x times what is 2x to the third. Carly, feel free to give it a try.
Wouldn't it just be x to the third, because this is technically 2x to the first?
Yeah, so you have 1 here and you want to get to 3. So how many do you need?
Yeah, so 3.
Well, you're going to end up adding. When you multiply x1, you add.
Oh, that's right. So 2.
Yeah, so it's always 1 less. And that's actually true for all these. It's, that when it's a 1, it'll always be 1 less. You'll see that when we do synthetic, because it will have to be a power of 1 there. So now when I distribute that, I get 2x to the third minus 5x squared. So I'm going to subtract that quantity, or in other words, add the opposite. So those cancel out, and we end up with, my daughter's going to be leaving any minute.
Yeah, I'm loading her up right now. All right, come on, sweetness. All right, here we go.
So now, how do I get rid of this term? So 2x times what is negative 4x squared?
So then that would be x to the first.
Yep, and what would be the coefficient?
Uh,
Oh, it's chilly out here.
so 2x to the first.
And to make it a negative, you'll need a negative 2.
Yeah.
So negative 2 times 2 is the negative 4. X times x is the x squared. So I'll get that negative 4x squared, and I also have to distribute here. So negative 2x times negative 5 is positive 10x. So now you can hopefully see the benefit of having the 0 placeholder there so that you have these like terms aligned and you're not accidentally combining 15 with 10x, because those wouldn't be like terms. So it's not that you have to put in a 0, because you should know not to add 15 and 10x. It just helps prevent accidental combining of unlike terms. So when I change this to adding the opposite, these go away, and I have negative 10x plus 15. And so last but not least, 2x times what gets me negative 10x?
5.
Positive or negative?
Negative.
Okay. So negative 5 times 2x is negative 10x, and then negative 5 times negative 5 is positive 25. So we're going to subtract that whole quantity. And we can change it to adding the opposite. Negative 10x plus 10x goes away. 15 minus 25 is negative 10. And that is coincidence. Not all remainders are negative 10. It just happened to be the case for both those two examples. Another thing I wanted to comment on is sometimes students see the 10 and the 2 and they want to divide that, but you have to divide the 10 by 2x and by negative 5. And so that's as far as you can go. There's no way to simplify that. We'll talk more about simplifying rational expressions in which section? That's in chapter 6, at the beginning of chapter 6. So that's a method. This long division is a method that works no matter what your divisor is. It could have a 1 or 2 or 3, a negative in front of the x as a coefficient. It can have any exponent you want. It could have 2 terms like this, or it could have, like, many, many more. It's a method that's very flexible. Synthetic division is a shortcut, but it has some limitations to it. So synthetic division is where you have to have a divisor, the denominator, be x plus or minus some number. And so the leading coefficient has to be 1. It has to be 1x. It can't be like 3x. It can't be this 2x minus 5, because then it won't divide out in this shortcut way. So let's take a look at this example. So synthetic division, as I said, is a shortcut, and a method to keep track of things is kind of like the sideways L. So it's 2 lines worth. We put the coefficients of each of the terms. So this is the 5th power, 4th power, 3rd power, 2nd power. There's no first power. So again, we're going to put in a 0 placeholder, and you must do that because right now this is indicating that it's going down from whatever the highest is. So this would be the constant, the x term, the x squared, the x to the 3rd, the x to the 4th, the x to the 5th, And so if I didn't have the 0 here, this would have ended up being the x to the 4th term, which it wasn't. It was the x to the 5th term. So always put in 0 placeholders. For missing terms. All right, so then the idea is by bringing down this first coefficient, you're going to end up saying 2 times this x will get us the 2. Like, and we'll need to figure out what the exponent is. So it would be x to the 4th. And you're going to see once I do this whole problem why that is and how that works out. But we'll just do the method for synthetic, and then we'll talk about why that is some more. You bring down your first term, and then you're going to start saying, well, division is the opposite of multiplying. So I need to say this times that is going to give me this original problem. And so I take the opposite of my constant. So I'm going to put -2. And the reason I do the opposite is so that I can just add instead of having to do all the subtraction that I was doing before. The process is write down the coefficient, put in the 0 placeholders you need, take the opposite of your divisor's constant, bring down the first term, and then you start multiplying and adding. So you're going to do 2 times -2 is -4, and then you add. So you get 0. And you do 0 times -2 is 0. 0 times anything is 0. Then you add. Then -3 times -2 is 6. Then you add. 7 times -2 is -14. And then you add. -14 times -2 is 28. And then you add. So once you've got this set up, which is the purple part, then you just start multiplying by this and then adding each of the columns. So multiply and add, multiply and then add, multiply then add until you're all the way to the end. So that last place is your remainder. I like to put a little r next to it. This will be your constant. This will be your x. This will be your x squared. This will be your x to the 3rd. And there you go, x to the 4th. And again, when I write this down as an answer, I can skip over that 0 because I have 0 of them. It doesn't matter. It doesn't have any quantity, any value. 18 over my denominator, x plus 2. If I were to multiply this by this, you can see that 2x to the 4th times x does get me 2x to the 5th. And you can continue on. If you multiplied this whole polynomial by this, and then you added 18, you'd end up with this answer. So you can check your work. There is another way to do division, and that is by factoring, and that works when things are factorable. If they're not factorable, it doesn't reduce it. And we're going to do a lot more factoring, in the next couple sections. But essentially, I could say x plus 4 times x plus 2 is with this part. There's x squared, there's 2x, there's 4x, that makes 6x, and there's 8. And then x plus 4 in the denominator, because you're dividing by x plus 4. And then that's like saying it's dividing by itself, so it cancels out, it goes in one time. So I'd end up with x plus 2. But that is going to be the method mainly in the section once we've done more factoring. That's going to be like reducing a rational expression. So long division is definitely something that you need to know because it works in all cases. Synthetic is just a cool trick, but you could have done the same problem with long division. It just would have had more x's and taken a little bit more space vertically. So I've got some practice problems. I'm not going to do them all, but I'm just going to mention like this one would have to be done with long division because of the 3 there. This one would have to be done with long division because of the x squared. This one you could do either way because it's just x plus or minus a number. This could be done either way. And I say both ways on here just so that you can compare the fact that you get the same answer regardless of the method. And on this one, you would also need to put in a 0x squared. And then the last one, it can again be done either way, but it can be done with synthetic because it's 1x to the first. That's a number. Would you like to give one of these a try?
Sure.
Do you want to try synthetic or long division, or do you want to do both?
Synthetic, because I'm more familiar with the long division.
Okay. So why don't we take a look at one that's a little bit better maybe for practice. From there, let's see which one would be a good one. Well, we could do, let's see. I wanted to see if there was one where we had a 0. Okay, why don't you do well, whichever one you want to do. You can do this number 4 here, or you can do number 5 if you want. 5 is a little more straightforward because it doesn't have any zeros.
Let's go with 5.
Okay. Do you want to talk this out with me, or do you have paper and you just want to work on it yourself?
I have paper, I just don't have a pencil, apparently.
Oh, okay. Do you want to kind of tell me what to do then?
Okay, so first thing we have to do is put the -1, because we have to do the opposite from the x plus 1 on the outside of it.
Good.
And then on the inside top row, we have to put 1, or no, yeah, right?
Yep, 1.
1 and then 7. And then the 15 and then the 8.
And so this one didn't need any 0 placeholders because it's 3, 2, 1 constant, but that would be something you'd want to definitely make sure of.
Yeah.
All right, now what?
Okay, so then you would do the -1 times 1. So -1.
Okay, first.
Because you would drop down that first one in the first problem. So that's
Okay,
automatically
then
the
yes,
answer.
then 1 times -1. Good. All right, now what?
And then you would subtract the 7 from the -1. So 6.
So subtract 1 from 7. Okay, you get 6.
And then you would multiply the 6 by the -1. So that would be -6. And then subtract the -6 from the 15. Which
Okay, so you're just so we're clear, you're gonna subtract 6 from 15, not subtract -6. Because that was
right.
But I think you were doing the right thing. You just weren't saying it quite.
Yeah.
Your 15 minus 6 is
9.
Yep. And then last but not least.
And then you multiply the -1 by 9, which is -9. Which would then leave us with -1.
Yep.
And then automatically that makes the -1 a remainder. And the 9 is our constant. And then a 6 would be x to the first. And then 1 would be x to the second.
So you could write it like that, or you could just, instead of putting plus and minus, you could say minus and then just do a negative, and then just do a 1. Good. And if there's a 0 on the bottom here, as we saw before, you can leave that term out. If you accidentally forget a 0 like placeholder, then these don't end up being 1 lower. So right now you can see this is x squared and this is x to the third. That's a good sign. And so sometimes people, instead of starting at remainder, they go 1 less and they say squared, then x, then constant, then remainder. I've just found more success with students when I start with remainder and work my way up. But it's up to you if you want to do 1 less and work your way down, or start at remainder and work your way up. Good job. Okay, and there's more examples online as well, in the module and on YouTube and things like that. So that is 5.3. 5.4 is greatest common factor and factor by grouping. And so the greatest common factor is when you look at all the terms and they all go into something evenly, meaning that you could divide by it and there be no remainder. So for example here, these are all even, and so I can factor out a 2. That is the highest thing. And I mean, this has 2, 5, 1, and 10, but this only shares the 1, which is not helpful, and the 2 with the 10. Same with these others. So I can take out a 2 for the numeric part, and then for the variable part, they all have at least an x. So I can divide out an x. So essentially what I'm doing is I'm now dividing this by 2x to undo the fact that I'm multiplying here. So if I divide, I'd end up with 5x to the third minus 8x squared minus 1x, or just x, and then minus 7. So in other words, 2x times what gets me this? Well, 5x to the third. 2x times what gets me this? Negative 8x squared. 2x times negative x gets me that, and 2x times negative 7 gets me that. So you can double check by distributing, or you can just say to yourself 2x times what in order to fill it in. That way you don't have to like do all your division. So it's up to you how you want to approach it, whether you divide to see what the expression is when it's factored out, or if you just think to yourself what makes it multiply back correctly to your expression. Sometimes you'll have multiple variables or higher coefficients. If we look at this one, again, they're all even. I did a lot of 2s just because it's easier to see and get the point across. But they all have at least an x, and they all have at least y squared. So you want to pick the greatest common factor. So I picked y squared instead of just saying y. So this would be 5. We already have an x. We already have y squared. Plus, I need a 3 to make the 6. I need x squared times x to get me x to the third. I need y to the third times the square to get me the third. So in other words, I can say I already have 1 out. I need 2 more. I already have 2 out. I need 3 more for the y's. And minus 7. I need 1 more x, and I need 1 more y. Or you could have divided by that 2xy squared for each term and gotten that. And then when you multiply back, it's the same expression. This next one, I'm not going to do it completely, but I did pick something that had something other than 2 that could come out from each of those. Now I'm trying to figure out, maybe I didn't. That was a different problem. I've changed my problems up. Yeah, I changed the problem. It used to be something different. It used to be 16 and 36, which a 4 came out of, but this looks like 2 is actually the highest thing. W squared and a y. And so 25w squared, I already have the y, so I don't need to say it again, because when I distribute, I'll get the y. Minus 9, I'll get the y, I'll get the w squared. And if it is exactly the same thing, then you have to put a 1 so that when you distribute, you get it. You can't just like leave it out. Otherwise, when you multiply it, it won't get you what you needed. This can actually factor further. We'll talk more about that later in this session. But it is a difference of squares. And so it can factor further.
So then with problems like that, is it always just the greatest common factor of the numbers that you take out?
That's where you always start with factoring. You always start by looking for the greatest common factors. And then sometimes you can factor further and other times you can't. And so the rest of these sections are really on factoring techniques so that you'll start learning like, oh, this can be factored versus this one cannot, or, for example. So yeah, you always start with the greatest common factor. Bless you.
Okay.
So one of the methods I didn't learn until much later in my education was this method called factor by grouping. And that's used when you have 4 terms. It also can be used when you have 3 terms that get broken up into 4. And you'll see that with basically it's another way to deal with factoring when you have a trinomial when the leading coefficient isn't 1. And there's 2 methods for that, but this grouping is definitely a nice one that as I said, I learned it later on and I really like it. So the idea is you're going to cut the polynomial in half. So basically you're going to group it into 1/2 and another half. Then you're going to factor each part. You're going to factor each of the, so when you cut it in half and you had 4 terms, you're going to factor the first 2 terms and then you'll factor the second 2 terms. There's a note I want to make about negatives. So if your third term, this is a brand new pen. It's not the nicest. It's got a very sharp point, so it doesn't write smoothly. I'm gonna have to, but I like that I can change colors. I'm gonna have to figure out a different option though. First term has, so if the third term has a negative, you have to factor out a negative when you're doing your factoring, and you'll see why. Really, if you don't do that, things don't match up and work out nicely. So, but it's just kind of a reminder that you actually factor out the negative. Okay, and lastly, you'll factor out the common factor. All right, so let's try those steps. So here's a polynomial. It's got 4 terms. So, and it's nice when it's in standard form because if it's not, then it's harder to factor. So I don't say that it should be in standard form specifically on this. I do here say to put it in standard form first. Typically, you'll be given problems in standard form. Sometimes they work out when they're not in standard form, but it's kind of hit or miss. So here we are going to factor this half. So I can take out a y squared, and then I'll have y plus 2. And then I'm going to say plus, so this when I distribute is this, plus, and I'm going to distribute or factor out an 8 here. So then it's y plus 2. So again, you have 8y, you're going to add 8y, and you're going to add 16. And so these 2 expressions are equal. So I've written it so it's like this partially factored thing. It's not factored yet because you have an addition. But step 2 says factor each part, and then step 3 says to factor out the common factor. So there's got to be this common factor for this method to work. If these are not common and you're in this section, it's probably that you made a mistake with factoring out, like maybe you factored out a 4 instead of an 8. And that's why they didn't match. Or you forgot to deal with your negative correctly. So that's why they don't match. But in general, if you get it so that these don't actually match up, it means it's not factorable with this method. And you'll learn how to do those in like in a pre-calc class. So for right now, I can say, well, I can factor out this y plus 2. So I have y plus 2 times what? Well, y plus 2 times y squared, and I have y plus 2 times 8. And so now it's factored because it's something times something else. And we'll also look more at binomials and when they're completely factored or not as we go through this, but there's no such way to factor this binomial in that review assignment. It'll be kind of clear that you can't do that. The only time you can factor a binomial is if it's a sum or difference of cubes or a difference of squares. Otherwise, it's just a GCF, and there was no common thing between all 4 of these terms. And there's no common thing between y squared and 8. So I want to do one more with the subtraction in there. I do want to note this is the common factor. I like to put it out in front because I like to factor out common stuff. And then this is kind of like leftovers. I mean, that's kind of my own term for it. But what's left over from factoring out this is y squared plus 8. All right, so let's do one with a negative. Let's do this one right here. So first we'll put it in standard form. Again, not required, but it'll make it more obvious. So I'm going to do 6x cubed minus 8x squared minus 15x plus 20. And cutting it in half. Factoring out, I'll factor out a 2x squared. So I'll have 3, 2 times 3, 6, and then I already have x squared. I just need one more x. And then minus 4. 2x squared times negative 4 is negative 8x squared. And then here, we're going to factor out negative. And they have a common factor of 5. So negative 5 times 3x gives me negative 15x, and then negative 5 times negative 4 gets me the positive 20. So when you factor out this negative, you'll have to change this sign because that's what happens when you have a negative. Negative times negative gives you a positive, so it has to change in order to have factored out the negative. So now we have this common part, so we'll factor it out, and then the leftovers. And again, binomials, you can only factor when it's a difference of squares, and these are not squares, or some are difference of cubes, and these are not cube things. So that's as far as you can go with both of those. Do you want to try one of these grouping things, or have you had practice with it in the past?
Very, very little.
Okay.
Like, I'm looking at one in the homework, so I'm kind of like going along in the homework as you're saying it, and then seeing if, like, by going through yours and the homework, if I get it. And like, I'm looking at one in the homework right now.
Okay.
And so it's just 2s and 5s, and it's exactly like that last one that we just did.
Okay.
Where the third one is a negative, and it's to do it by grouping.
Okay. So what does your problem say?
It's 2xy to the second plus 2y to the second minus 5x minus 5.
Okay. So walk me through what you're thinking.
So then it, from what I'm seeing, the only thing that can even be taken out is that negative term.
Okay. So you're cutting it in half. What about here, the 2's?
Okay, so you would be able to take out the 2 and then take out a -5 from the other one
Yeah,
because we're separating them?
yep, 2 and a y squared.
Oh, okay.
And this is what I was mentioning earlier, like if it's itself, you still need to put a 1 so that when you do this, it'll end up matching. You still need like,
Yeah.
be like 2 times 1 gets you 2. You can't
Yeah.
just leave a blank there. And then you set it -5. And then so then this becomes x, and your sign will have to change so that -5 times +1 will get you that -5. So these expressions are equivalent, and then these match up. So that's kind of the key to this. So x
Yeah,
plus,
so then the first parenthesis would be the x plus 1, and then the next one would be the 2y squared minus 5.
exactly.
Okay.
Good job.
Okay, that's what I thought. I just wanted to double check.
And sometimes when the numbers are bigger, or you're like, I don't know what the greatest thing is, sometimes I do this one first, and then I'm like, oh, it needs to be this. So what makes it that is 2y squared. This isn't a very difficult problem with the numbers 2. I mean, it's kind of obvious it's 2, but sometimes there's like, 54 and 107. You're like, I don't know what the greatest common factor is. And then you do the other half, you kind of get a hint. All right, so that is 5.4. 5.5 is on all these factoring, and when I was in school, we kind of learned it by guess and check. And it's beautiful in some ways because it really helps you think about your factors of your numbers and your signs and just critical thinking. But it's not the most efficient way of doing it, right? Guess and check, you have to guess and check several times sometimes before you get it. So there's this other way that's a little more efficient that I'd like to share with you, and it's called the diamond method. Have you heard of that before? Or the X?
No.
Okay, so let's we're thinking about polynomial or trinomials in particular, so 3-termed things, and they are of this format where it's something x squared plus something x plus some constant. And so, as I mentioned on this last section, you always want to take out any common factors to start. And if something can't be factored, it's called prime. So here is kind of the shortcut method, and you're welcome to rewatch this video once you have a pencil and can write it down. A lot of people call it the diamond because if you can make a diamond around it. I just don't make the diamond shape. I just do an X. So you can figure out what multiplies to your A times your C value and what adds to your B value. And because your A is going to be 1 for these first couple, there's a shortcut. Because it's 1 times C is just C. So you put your constant towards the ceiling, the C towards the ceiling, and you put your B towards the bottom. That's just an organizational structure. It doesn't technically have to be that way. You could say adds to the B here and multiplies the A times C or the C down here, but this is the traditional setup. So if I'm trying to factor this problem, I'll do it with an example and I'll finish that up. So I would be saying what multiplies to 1 times 8, or 8, and what adds to 6. So your textbook talks about what multiplies to the A times C and adds to the B, and they make a table. And that's fine, and you can do it that way. I find that this is even quicker normally than making a whole table. So we have to ask ourselves now, what multiplies to 8 but adds to 6? So what 2 numbers meet both conditions?
4 and 2.
Beautiful. So what do I do with those numbers? What does that help us with? Well, you know that you have an x times an x for your FOIL, that gets you x squared. And it's
Yeah,
really
and then wouldn't it be x plus 4 and x plus 2?
exactly. So by doing that diamond, you've got what you're going to fill in your factorization with. So sometimes we call this like f and g, and then it would be x plus f, and then x plus g. So that's when the A is 1. Let's do one more of those. Let's do this one right. 3. So 1 times 28 is 28, negative 11. So it's the A times C. You can write just C when it's always 1, but when it's not 1, you're going to have to do the A. So I want to get us in the habit of just doing A times C, so it's always the same for all of these. So it's not like on these I do this and on these I do that. So there's already going to be a little bit of that as it is. So now I have to figure out what multiplies to 28 and adds to negative 11. So if we're multiplying to a positive and adding to a negative, both of these are going to have to be negative. And this is how I used to have to do some of this, was because I was guessing and checking. I have to pay attention to the signs. So 28, it's 1 times 28. It's 2 times 14. It's 4 times 7. And I'm generating this list pretty quickly because I'm just doubling and then having, doubling and then having. And that's a quick trick to get more factors. Or you could triple and take a third. You might skip a few and you'll have to go back and go, oh, does it divide by 3? Does it divide by 5? Does it divide by, if you're not finding it. But this is a nice way to generate a pretty good list. So because they're both negative, which here add up to 11?
The 4 and the 7.
And so I'll have 4 and 7 here. Just double check that your signs work out and that your product and sum work out. Sometimes it is really close, but the sign is off. So you just want to double check. So this would be x minus 4, x minus 7. I'll quickly walk through this last one here. I would first take out an x, because that's a common factor. And then I'd see if this trinomial can be factored further. So my A is 1, so I'm going to set up my little x thing. What multiplies to negative 18 and adds to 7. So this time we have a negative here and a positive down here. So to have it multiply to a negative, one of them has to be positive and one negative. To add up to a positive 7, we must have more positives. And what works then is positive 9 and negative 2. And so my answer would then be this x and then x plus 9 times x minus 2. And you can always FOIL and distribute and check that these are equivalent. So that's one with a greatest common factor and with signs being opposites. When your A is not 1, there's an extra step, because here it was really quick because it's x times x is x squared. You got your first term. But here, if I were to do it, x times x would not get me 6x squared. So there's an extra step to make it work out when A is not 1. So the trick is you can still do diamond, your little x thing. You can still do your A times C and add to your B, but you'll have to do one more step. So I'll just call this H and J, just so it's different than above. And so then you'd have your AX squared term plus HX plus JX. So you're representing this middle term by splitting it up into 2 in such a way that it is now going to be factorable. And you can see you have 4 terms now. So again, this and this allow you to break up that middle term so that it's factorable. So now we're going to do the grouping. So then factor by grouping. So let's try one. Let's do this first one. So 6 times negative 5 is negative 30. That's what I'm going to multiply to, and I'm going to add to my middle term, my b on the bottom. And you'll get more comfortable and faster at doing these as you get more practice, and if you're better with your multiplication table, it's a lot quicker also. So if you get stuck on these, you know, as I said before, you can make yourself a list. You know, it's 6 times 5 gets you the 30. Don't worry about the sign when you're making your list of factors. You could, you know, try doubling and halving, or halving and doubling in this case. I could take a third and then triple. Or if you didn't realize you can take a third and triple, you could also say, well, it's even, so I know 2 works. So that's a pretty decent list. Of course, one that gets forgotten about a lot is the 1 times the number. So I ended up getting -10 and 3 because one of them has to be positive, one negative to multiply to a negative. So I'm looking for a difference of 7, and the one that has a difference of 7 is the 3 and the 10. And I just want more negatives to add up to the negative. So now I'm going to rewrite this expression as 6x squared minus 10x plus 3x minus 5. Or you could put the 3x first and then the -10. If you put the 3x first and then -10, you'll have to remember to factor out that negative. So sometimes it's kind of strategy on my part to put the negative in front if I have a positive and a negative for the middle term. So I'm going to cut it in half, factor out a 2x. That's 3x minus 5. Factor out, and this is one thing we didn't really talk about with the grouping earlier, is, well, what if there's nothing that factors out? Well, actually, there always is. It's 1. We talked about 1, you know, for one of these things, but not out here. So there it is. 1 times this gets you that. And you do need to always have something, because when you pull out your common and then you pull out your leftovers, if you didn't have the +1, well, then it wouldn't get you back to this original expression. So there's your final answer. Again, there's that 6x squared, 3x minus 10x, that's at -7x, and then minus 5. So you can always check your work by foiling. Have you seen that method before with like this x and the grouping?
I've seen the X method, but I've never seen you then move into grouping.
Yeah, I hadn't either. When I was, in fact, I taught high school for 9 years before working at the college. And the method that I used was kind of like unmultiplying. So like when I used to multiply, instead of using a FOIL, you can also do it in a box. And so then I would basically unbox the situation. So, I mean, it was pretty similar, except for what I would do instead of doing the grouping is I'd say, well, I have 6x squared here. I have -5 here. My middle term is -10x and 3x. And then I'd factor each column in each row. And there's my answer, 3x minus 5 and 2x plus 1. So it's about the same amount of work, really. You might like this more, you might not. It's up to you. It's, you know, we factored this in one step and got 3x minus 5 rather than in 3x and then -5. And then again, this in one step rather than the 2 steps. But it is a nice organizational structure, and it's, if you don't know grouping, because we used to have grouping later on, like grouping was done like in Algebra 2, or as I said, I don't even remember doing grouping until I was in college, and I was like, what are you guys doing? And they told me that it was grouping. So when I was doing it before, I always had to do it by unboxing, essentially.
Yeah, I've never heard of grouping until today.
Oh, cool. You learned something.
And it's so much easier.
Awesome. Yeah, I like it too. As I said, I do it now. I just, but you don't have to do it that way if you have another method. So when the A is not 1, or there's other variables, or they're not quadratics, they're not ax squared plus bx plus c, there's different things you're going to have to pay attention to. So I'm just going to project a few little comments. Again, any LCDs need to come out. So this has a -3. I like to make it positive for my leading coefficient. So instead of taking out a 3, I'm taking out a -3, which just like before changes the signs. And then that's normal. Here, since you have a y squared at the back, you'll need a y here. So that y times y gives you y squared. And that way you get a middle term with x's and y's. And then last but not least, if it's not squared, starting, you know, x to the 4th, it might work out where it's split up x squared and squared. Technically it could be x to the 3rd and x, and so there's this u substitution we'll learn later on that oops, I think my mother-in-law is calling, leaving a message now. Okay, so we'll talk more about that method, but for now, if you see an x to the 4th, it's x squared and x squared. And then the rest is the same. You just deal with the 24 and the 11. So that is 5.5. And last thing that I'm going to mention for tonight is the special products. So the main one we're going to be dealing with is going to be difference of squares. It's going to show up a lot. And so basically, in order for that middle term to cancel out, to have no x's, your O and your I of FOIL need to cancel out. So it's kind of like me saying 0x here and then going, what multiplies to -25 and adds to 0? And we have opposites. We'll add to 0. And so x plus 5, x minus 5. And so this ends up being just what was squared is, and then what was squared, one having a plus and the other one having a minus. And so in your XYZ homework, when you see binomials, two-termed things where they're both squares and a minus in between, then you can take this square root, or you can say what squared gets me that, what squared gets me that. One of them has a plus, one of them has a minus. This one actually can be further factored because it's a difference of squares. So x plus 3 and then x minus 3. There's a few others in your homework that look like these next couple. So like you could have this plus the 7 and this minus the 7 and then combine like terms. And then we'll also have problems with difference in sum of cubes. So again, binomials, but this time it's cubed things. They don't show up quite as frequently, but you definitely will be tested on it. It does come up on your tests. And the only way you can get it to be factored is by knowing this pattern. So it has to be memorized. There's no way to factor otherwise, unless you're just guessing and checking and it would be a very difficult guess and check. So the idea here is that you are going to, where did that sheet go? So if we do one from scratch, let's do this one right here. So what's cubed is 8x cubed. So what cubed gives you 8 is 2. And what cubed gives you x cubed is x. And then the minus just tells us which rule you're going to use. So then you're going to look at this to figure out your b. So what cubed is 27? That's 3. And then a y. And so because it's the minus, it goes the a, so what was cubed, minus the b. Then it's a squared plus ab, and then plus b squared. It always ends on a positive note because a negative times negative will always be positive, and a positive times a positive will always be positive. And then this negative times a positive will get you your negative, or here you'll have a positive times a positive to get you your positive. So these rules need to be memorized, and all it is figuring out what cube gets you your a and your b, and then you plug it in. So 2x is my a, minus my b, which is 3y. Now I'm going to square this. So 2 times 2 is 4. X times x is x squared. And then I'm going to add my a times my b. So that's 6xy. And then I'm going to add my b squared. So it's going to be 9y squared. And as long as you factored out anything in common at first, these don't factor any further, like 99% of the time. So once you've applied the rule, you're pretty much set to go, but it never hurts to glance it over and make sure, especially if there had been a common factor. Let's do one with a plus. So this is going to be 3x, and this is going to be 4. And so the plus goes a plus b, a squared minus ab, and then plus b squared. So we're going to have 3x, the a, plus 4. And then we're going to have this squared, so 9x squared, minus the a times the b, and then plus my b squared, so plus 16. And you could always all the middle terms cancel, and that's what you're left with. And again, when you're squaring this, you're squaring the whole thing, so it's not 3x squared, it's 9x squared. And this last one doesn't look like anything is being, I mean, this is a squared thing. That's not a squared thing. It's got a cube. It's a plus, so it's not a difference of squares, even though 16 is a square number. It doesn't look like a sum of cubes, but once we realize, oh, these are both multiples of 2, and we take out the GCF, this actually is a perfect square with terms. And so your final answer would be this 2, the 2 plus 5m. You're going to square that. You're going to now do minus this times this, and then you're going to do plus this squared. Don't forget to bring down that GCF. Sometimes people forget and they write this down and they don't bring the 2. But you have to have it eventually end up equivalent to your original problem. So the last thing that I'm just going to project is a general review, and I'm happy to email you this as well. But basically, if you have 2 terms in your factoring, it's either a difference of squares, a sum of cubes, or a difference of cubes, or it can't be factored. And I put down the rules for how to factor those right there. For 3 terms, when it's the quadratic, meaning the highest exponent of 2, when the a is 1, then it's what multiplies to the c and adds to the b, and you can use that x thing, or you can use the guess and check. When a is not 1, then you'd have to do your a times your c and what adds to your b, and then you're going to have I guess I used f and j before, jx. And then grouping. I guess I should do the grouping right. I keep trying to do that right before the plus. And then there's a few other special cases, but you don't need to memorize these because you'll just realize it as you do it. It's just a shortcut. If you realize that the first and last term are perfect squares, it might be that the whole thing is a perfect square polynomial. I actually do have one example I can project of something like that. It was that back page here. So y squared and 36, they're both perfect squares, and this is 2 times what was squared and what was squared. And so it would be the y, the 6, plus, because you want to end up being positive 12y squared. It's a perfect square of that. Versus or like number 11, this is a perfect square, that's a perfect square, it's 3p and 5. This is 2 times 3p times 5, so it is a perfect square. That, put a plus. Here's a minus situation. That's a perfect square, that's a perfect square. This one has a y squared at the end. So what was squared, that is twice the two things. And so it is a perfect square. So it's a trick, but you didn't have to do it by analyzing the perfect square. You could just do it with a normal x and the grouping. It just might be a little bit more work, or the numbers might be a little bit larger that you're working with. So it's a cool trick if you recognize that there's a perfect square at the front and the back of the trinomial. You just have to check that the middle is twice what was being squared. And so that's why it has twice the two things that were being squared. If it's a plus, it's a plus. If it's a minus here, if it's a negative, then it's a minus. So that was what this part is for special cases. And of course, you might have a trinomial that's not factorable. 4 terms is the grouping. And again, if it doesn't work that way, it's either not factorable or we just don't have a method in this course to deal with it, but it could still be factored in calculus. So that's really it. I mean, I have a few more challenging examples. I'll project just in case you want to reference it while you're doing your homework. But it's really, this is a review of what we already did. If you have fractions, you know, don't be too scared. You know, if it's a difference of squares, you can do the diamond thing, but it's a little bit harder with fractions. As you can see here, it is with fractions, but that's harder than recognizing the other properties. So I did put a few more challenging examples in here where there's a GCF, or when the A is not 1, or when you have to factor out a negative, or when you have more fractions, or when you first have to factor and then you're left with something that you can factor further. So if you are wanting examples that are a little more challenging, here's a sheet with it. So I'm happy to send that along to you as well if you like it. There are some problems similar to this in XYZ, so it might not hurt to have it as a reference if you get stuck. So that's it for tonight. You have any other questions?
Nope.
Okay, so do you want me to email you then or message you the 5.7, these examples, and the like cheat sheets that we just did? Would that be helpful?
Yes.
Okay, I will do that right now. All right. Otherwise, have a good night. Message me if you ever need help.
I will do.
Okay, bye.